Thank you, Adam, and thank you so much and your team at KernelCon for inviting me to speak and doing all that you've done. I know you've slept probably less than 10 hours the last 7 or 8 days, so we really do appreciate it. And thanks to the sponsors. Without them, the conferences don't usually happen. I got to thank Contrast Security. They're one of the sponsors as well, and where I work. So today I want to talk to you all, and thank you for being here. The last one of the day of the conference, you guys are troopers. It's a hard one. I want to talk about knowing what risks matter and don't in your open source. It's a very relevant topic with Log4j and Spring for Shell and all the other things going on. So this is me. Adam kind of explained I'm the CISO at Contrast Security. I've been around the block a bit. Most of my career I spent in consulting for application security teams across the government space, Federal Reserve, Treasury, into the financial sector, and so on and so forth. And I've been at Contrast for about 3 years now, focusing mostly on securing our own stuff and providing support to our product team, since we are a product security company from a research perspective. So before I dig into kind of the guts of the talk, I wanted to talk about what we're seeing, and COVID time and all of that. It really changed the mentality of products and engineering and all of that, because all of a sudden we're all at home now. We don't necessarily have the collaboration we had before. So we saw a big disruption in the industry. And it really pushed forward the digital transformation for executives and the other CEOs and so on and so forth, to move those plans up and change their roadmaps very, very quickly. They didn't have a choice. Nearly 50% of CEOs increased their long-term investment almost immediately when COVID hit and we started working at home. And so what that did is, the software factory changed. We're now all remote. We're creating code remotely. Before, a lot of times they'll come in and they've got their desktop sitting there. They're not even at home with a laptop. So now we got to think about things a little bit differently. And at the same time, organizations were already looking at moving from waterfall, agile fall, DevOps, all of that transformation and shift and move. So it's really been an interesting last couple of years for sure. And in that, one of the things that really came to light is the entire software factory ecosystem. It's not just open source, it's not just the vulnerabilities that your developers may create, which is really the traditional thought process when it comes to, how do we get hacked? But it's also the tools that we use, the pipelines and everything involved. So there's different attack vectors now that are being taken advantage of. So you got the traditional one here all the way on the right. There's a vulnerability in your application that your developers introduced, and you get attacked via SQL injection, cross-site scripting, what have you. For years, we've dealt with attacks on our open source. We're bringing open source in, and that's really what this talk will focus on. But we're seeing more and more of that, Log4j, Spring for Shell, all of that. But we also have seen attacks on the other pieces and parts that are kind of newer in this digital transformation time, and that's our build tools, the process, the pipelines, the things that we're using to get our code from point A to production, right? SolarWinds, anyone? That was really a big eye-opener for the industry, that software factory was attacked, and it really affected a whole heck of a lot of different organizations. And then Matt Austin on my team and some others really dug into dependency confusion when it comes to open source and making sure that you're actually pulling the library that you think you're pulling, and pulling it from the place you're pulling it from, instead of incorrectly pulling it from a rogue library that is hosted publicly, even if it's for a few minutes. So we've really seen a lot happen in this whole software factory, in the past couple of years. And then, let's dig into open source, because that's really what I want to get into. And, when it comes to open source, there's all these things that we've talked about for years, and people don't like CVEs, but the reality is we're using more and more and more and more open source as time goes on. Why is that? Anyone? I like to be interactive, so just shout it out. Why are we using more open source? It's free, yeah. The work's done, yeah. Yeah, it's fast. Yeah, when an engineer has a problem to solve, they don't first think, how do I do it in code? They first think, did someone already do this, right? Because then they can get on that quickly and then improve it, right? So we're pulling more and more. There's a 40% annual increase in use of open source software. And this is a stat from 6 months ago, and it's probably more than that now. And then 90+% of organizations use open source. I'm not sure what the other 10% are doing. I mean, I would guess that everyone is really using open source. You know, and as we use more and more, we feel like the risk continues to grow because we know that vulnerabilities exist in that open source code. I mean, GitHub has a report out from, I think it was about a year ago, that a vulnerability exists in open source for about 4 years before it's discovered. So we know we're pulling in code, we're using it in our production environments that is vulnerable. And that's what I want to dig into today, because it may not be as bad as we're treating it. I'll just leave that as a little tidbit. So I want to talk about these open source risk layers, I'm calling them. And I list 5 here, but there's kind of a risk layer 0 that I'll talk about first. But the 5 that I really call out is active and inactive libraries, active and inactive library classes, library age, vulnerabilities, CVEs in those libraries, and then licensing risks, which doesn't come up very often necessarily in the security space. It's usually more of a legal thing, but it definitely is becoming more of an issue as we pull in more and more of these open source libraries. So risk layer 0 is really looking at the different ecosystems of the different languages that we deal with, the complexities of the different libraries that we're using from Java and .NET and Node. We picked these 3. We have a lot of stats on these. We have tons and tons and tons of applications that we have stats on here. And you can see that there's a dramatic difference between these 3 languages when it comes to library usage. Node, has a huge number of libraries compared to, say, .NET, and even Java, where it's somewhere in the middle. Any ideas of why the disparity? It's great. Node, 500 plus libraries and 65% of applications. That's crazy, right? And then you look at .NET, and it's significantly lower. Any thoughts about that?
Node sucks.
Node sucks. No comment?
Right. Very software built methodology.
Yeah.
Only starting.
Yeah, .NET is an easy one. It's mostly proprietary, managed by one source. There's not a lot of open source .NET libraries. But why Node? It's significant. 500 plus? That seems egregious to me. But the reality is the ecosystem makes that make sense. The way that the Node ecosystem works is a library has very few classes in each library compared to Java, and we'll dig into some of that as we get into the classes and two. But the other thing that I get out of this is there is a certain amount of libraries that are used in most every application. You look at Java, and the top 25 libraries are in over half of the Java applications out there. Does that open the door to anything? If I'm a malicious actor, what am I going to do? I'm going to target those 25 libraries, and I'm going to find the maliciousness and take over and find the vulnerabilities in those, because I know that most applications are using these, right? And so I don't have to work as hard to find the app that is using that library. And the crazy thing is you look at .NET, the one top library, one of them is used in 45% of applications, which is ridiculous. It's a huge amount. It's a system.service module web DLL. And then Node, top 25 are in 92% of applications. So there is some risk here, right? And I think we're running into it with the Log4j issues and then the Spring issues, and we're seeing this come to light. These ubiquitous libraries are the ones that they're finding issues in, and for good reason, because now they don't have to try as hard to exploit them. So risk layer 1, that was 0. Active and inactive libraries, it's not really something that the industry has really talked about much. And the reality is because there hasn't been tooling out there that can really tell you. Most of the SCA products out there will say, hey, in your POM you've got these libraries, so they're being pulled into your app. But are you really using them? Because one of the things that I've noticed, we're a small organization. We have around 200 developers, and even we struggle with keeping our libraries up to date. I can't imagine an organization with 3, 5, 10,000 developers. And the problems we run into are, we have this vulnerability, or this is out of date, and the security team's telling me to update it. We don't know if we're vulnerable. I've got to go work on this feature request. I don't know what to do. And then we burn our developers out. So we dug into that a little bit with the data that we have, using some instrumentation. We can tell when a library is actually used, and then let folks know about it. So of the libraries that are pulled in, on average across the Node, Java, and .NET ecosystem, 38%, only 38% are actually used at all. So we're pulling in a bunch of libraries that we don't even use. Yeah.
Is the rate at which the use of open source libraries increasing at a faster rate than the amount of people who actually look at the code and contribute toward that code and actually make improvements for it and feed it back into the ecosystem?
I would say the rate of usage of libraries actually goes down, and I'll tell you why. It's going down even though we're pulling in more, because how hard is it as a developer to moonlight something or get rid of it in your code? As your code base grows, you get to 1, 3, 5 million lines of code. How hard is it for them to just say, we don't use this anymore, and they remove it? They just don't do that because they're not sure. They just never had the data because their SCA tool says that it's there, and their AST tool says it's there, so they just remain. And which the worst part about it is they're remaining, and now we're still updating it because we don't know that we're not using it. Right? So having this data is going to help us from not only a security perspective, but for cleaning our code up, to know when we're using and actually using these libraries. So you can look at this and you can see there's a big disparity here, though. You look at Node, only 24% is actually used. So, Node pulls in tons. You pull in one, it pulls in 50 more dependencies that pull in 50 more and 50 more and 50 more. And all of a sudden you got this massive tree of libraries that your tools are saying, hey, you got these, you got to update them. And you're like, okay, I don't know what I'm doing. I don't know if I'm using it. Okay, we'll update it. And then you go to .NET, back to the proprietary type stuff, and 67% of that is actually used. So there's a big disparity between the two there, and then Java falls kind of in the middle. It's definitely one of those layers that it was kind of shocking to us when we pulled the data. And we could talk about this all day, but I pulled a little more detailed information about the Java library usage metrics here. So these were the top 25 at the time, and you can see there that most of those aren't, they're being pulled in and they're not even really being used. It's around 32% or so of these top 25. And you can see Spring Core was number 2 on the list. This is in ascending or descending order, I guess. But only 28% of that Spring Core is actually used, which is crazy. It's like, what are you pulling it in for then? Spring's not that old. But it's, these are stats that we've never really had insight into before. So I hope they help drive some of our decisions and help clean up our code and help us understand a real risk, and that's just risk layer 1. And I wanted to talk about Log4j when it comes to this because I truly think, based on what we're seeing, is SEA tools really over-reported the Log4j vulnerability. The reality is a lot of times Log4j is just used in a test environment for testing for whatever reason. It may be a transitive dependency on something else you're pulling in. Java, actually, most Java apps pull in multiple loggers, and they probably only use one, right? Logback, Reload4j, Bunyan, there's a handful of them that are very popular that are being pulled in. So it's one of those where it's like, oh, you have Log4j, you got to update it. Well, are you actually using it? So can you maybe deprioritize that or remove it from your code? And so if we look at Log4Shell by the numbers, if you will, 64% of Java apps actually packaged it, Log4j 2, and then another 26% packaged Log4j 1. Obviously, both of those were vulnerable during that time. So that's 90% of Java apps were packaging, some Log4j, if you will. Now, the interesting thing is, today, I took the stats today, 53% of the Java applications are still packaging vulnerable versions of Log4j, less than 2.17.1. And only 37% actually use it. But that's still a pretty high number, right? So there's still a lot of vulnerable Log4j out there that's actually being used. But these organizations obviously have not updated it or got burnout. I mean, how many of those did we go through in 2 weeks? There were 4 different CVEs. It's like, oh, someone said this one isn't as bad, and then they changed the CVSS score by the day. I can see why people were getting confused. So Spring for Shell, everyone aware of what this is? No one? Sort of? So on, when was this? Tuesday, Matt? So on Tuesday, a Chinese research firm is what they're saying. There was a random tweet that, oh my God, there's an RCE in Spring. Here's a link to a GitHub repo. Here's a picture of the calculator popping up, which is always funny to me. That's the common RCE pattern. And then all of a sudden, the tweet was gone, the Twitter account was gone, and the GitHub repo was gone. So we're like, well, shit, what happened? And then a few hours later, people started talking about it, and all of a sudden it turned into this massive confusion of some random commit to Spring where they said, they mentioned the word deserialized, so people were like, oh my God, there really is a vulnerability. Had nothing to do with it. There was another Spring Cloud Function CVE that was released, also nothing to do with it. And then everyone else is like, well, the other stuff must not be true, so we're going to ignore it. Well, it turns out it wasn't false. There all of a sudden more POC code started popping up, and we kind of dug into it, and it's, I'm not going to say it's as bad as Log4Shell, but it's a significant issue, and the numbers are saying it. 74% of Java applications package Spring Core. Again, only 28% actually are using it, but 74% actually bring it into their code. And for those of you that don't know, there are some requirements. You have to be running on Java 9+, you have to be running in Tomcat for the specific exploit that was released, and a couple of other things. But so we dug in and we found out that 71% of the Spring apps running on Tomcat, running on Java 9+, had at least one vulnerability that tied directly to this. So people are vulnerable. So we shouldn't ignore it. It's an RCE, it's bad, it's got a CVSS score of 9.8. And I used to say 100% of Java Spring apps were running a vulnerable version, but it changes to 95, I'm guessing, just because Spring did release a patch. So that's one, risk layer 1. Risk layer 2 is active and inactive library classes. So digging even further, right? So now we can tell if we're actually using a library. But what I want to know is, are we using the class that may be impacted? We don't always know that. But if I can say you're using these 50 classes, I can hopefully point that at a POC and be like, oh yeah, that's actually being used, we need to do something about it. So remember, there are 38% of libraries are actually being used, and of those libraries, only 31% of the classes are actually being used. So you start breaking all that down, and it's like 10% of the actual running code in your application is library code, even though 80% of the code that exists is library code. So it's actually, we used to, even 5 years ago say, oh, 80% of the code that you have in your apps is library code, which is true, but only 10% of it is actually being used. So it's really crazy. And the ecosystem kind of explains some of those early numbers too. The average Java library has about 279 different classes in it, whereas Node, it's 8. Right, so that's why there's so many more Node libraries being pulled into our apps, because they only do very little, right? Which is kind of how the Node ecosystem works. Whereas Java is like this monolith, right? They're the huge apps. They just keep building on and adding more and more functionality. And you can see again that the numbers being used as far as classes make sense too. Node, it's just 5%. That's 0.4 classes are actually used in a Node library you pull in. It's not even one. So it's just an interesting thing to think about. And then Java, 32% of the 279 classes are actually being invoked in your code. And it's information that I don't think we've really ever had before. I think back even a couple of years, we've had, I'm sure those of you that work in your SOC or your security team, you get reports from customers. Oh my God, you have all these vulnerabilities, you need to fix them. We ran this tool, and then you're like, oh fuck, what are we gonna do about this? We're pretty sure they're all false positives. Yes, we know we're running on a vulnerable version of this, but we're running a Java app in a web environment. We're not using the SSH component that is for client-server communication that does other things. And so you can tell them that, and it's like, oh, well, we don't care. You need to fix it anyway. So now that we can provide actual data behind it, I think we can move the bar a little bit to stop those fire drills that our teams are routinely dealing with, to update these things and fix all the things that aren't really problems. So risk layer 3, library age. Whew, these numbers were crazy. Libraries in general have now been updated for 937 days. That's 2.6 years, for those of you doing math, is the average age of the third-party library that our applications are using. And you can see the ecosystem is a little bit different. Java's by far the worst, .NET's a little bit better, and Node's kind of in the middle. Why? I know why once you get to a point, but 3 years? Why? What is going on? Well, the reality is once you get past kind of that point of no return where there's a breaking change in a library, it is impossible to update it. And so they just keep running. What does that do to the risk, though, of the application? Yeah, Ian, what's up?
Are you saying within your application you don't run, you don't update the library, or the library doesn't get
Great question. The question was, are you saying that we don't upgrade it or the library isn't updated? It's the former. So the developers writing the code, they're using the library, aren't updating their things, even though, look at Node. Node gets updates daily in some cases for some of the libraries, but they're not updating it in their code. And only 28% of libraries that are in use are less than a year old. So we obviously have an issue when it comes to library age, and it really goes hand in hand with the next layer 4, when it comes to the different vulnerabilities. And this is the piece that I want to dig into, because I think this is the piece that we're getting completely wrong. Is vulnerabilities in libraries. And tying into the age thing, the likelihood of a critical CVE being in a Java library increases from 7% at a year old to 44% at 4 years old. That's a significant increase in likelihood of having a critical CVE attached to it. We know Java has some issues, but the longer that sits there, the more likely that you're going to have a critical issue in that Java library. But you can look at this here and, applications with at least one CVE, I mean, they're all off the charts. We know we have CVEs, and the average Java app has about 50 open source vulnerabilities that are known running today. Toga, all right. Sounds like a party over there. And the odds are that 16% that a given Java library in an application will have a vulnerability at some point. However, the false positivity rate is about 23% for Java apps. So we're calling this false positives. If there's a CVE in a library, but you're not actually vulnerable, that's a false positive in our eyes, right? But we didn't have the data before. But now we know you're running this library, you're using it, you're using that class. Now we can say, hey, we are actually vulnerable very easily with the data that we have, and then make some risk-based decisions from there. If you look at this chart, what does it say to you? That is definitely the case. It's not as vulnerable as it looks. However, should we just write everything in .NET? I love your answer. No, I don't think that's what this is saying. I think it goes back to some of the proprietary stuff. We don't know what we don't know. I don't know if they release all the security issues that may be in .NET libraries. It's obviously significantly lower than the other Java and Node ecosystems, but I don't think that says, oh, let's just change and write everything in .NET, because no one wants to be on Windows machines. Sorry if you love your Windows. And does that translate to Java being a higher risk? I don't think so either. Just because we know about it doesn't necessarily mean it's higher risk. That's what we're trying to get at here. Just because it exists doesn't mean we're actually vulnerable to it. So, we can start to really kind of dig into this. There's really a correlation between the number of libraries and false positives when it comes down to it. You can look at Java here. The number of CVEs that are false positives based on the data we have is about 23%. And the number of critical and major CVEs that are false positives is about 17 for Java. So that means all the CVEs that are in your app, you've got quite a few that they're not actually affecting you. It just shows up on some dashboard and your CISO gets mad because it's red. Right. Yeah, go ahead.
Is it worth your time and effort to have scanning tools to help you identify the libraries that aren't actively being used in your code so that you can excise them from your code and therefore have a smaller attack surface for false positives?
I am always a fan of trying to clean up your code. I would try to get my bang for my buck and get that in a security product if possible. So you get kind of both. So yes, it's actually being used. Yes, I'm vulnerable, or it's not used. And then you can have a process around, deprecating or removing those things from your, and decrease that, and not have to answer to customers when they run some random scan and say, hey, you're vulnerable. And we're like, no.
It seems like you reduce the amount of libraries you're using, therefore they have less to complain about.
Definitely. Again, I am always a fan of trying to clean up your code. It is hard though. I mean, this is hard data to come by, and sometimes it's easier just to leave them, and that's unfortunate. So, however, who here has a really good risk rating system that they're using when it comes to CVEs? Who here just uses CVSS? I expect most hands to be kind of like this, right? CVSS is okay. It gives you a starting point. the common vulnerability scoring system. Every CVE has a rating between 0 and 10, but the reality is, I think it was last month, the average CVE that was released was about 66 of them was above a 7. Everything's bad, right? I mean, let's be real. No one submits a CVE for an informational level type thing. They don't get the notoriety. And it's a lot of work for the CNAs and all of the folks involved. So I like EPSS. Anyone know what that is? It's kind of new. It's by First.org does this as well. It's the exploit prediction scoring system. These are actually now listed with all CVEs. It takes in a lot of data to generate this. It looks at CPEs, looks at if there's any published exploits. They actually have a ground truth group where they pull in data from some of the major, I would say, networking level things, kind of like CISA Jen talked about this morning, similar. They're pulling data from that and what's going on in the industry. And they have this score that they score all CVEs on, is like the likelihood that's actually going to affect you. I'm seeing more and more of it used. I think we should start using that to help us make informed decisions. What about CVE trends? Anyone use that? So this is a decentralized intel source put together by Simon Bell, just some random guy on Twitter that crowdsources intel on CVEs. What are people talking about? What are the things that have all of the tweets going crazy and Reddit and NVD and GitHub? And he pulls it all into a nice looking interface at cvetrends.com. So I like using that because it gives me an idea of what's being blasted all over the place. Because malicious actors are looking at that stuff too. It's like, oh, cool, there's a new Spring RC. I'm going to start looking at that. And you can filter it down from the last 24 hours or 7 days. So that's pretty cool. So let's walk through an example. So let's look at Log4Shell. There were 4 distinct CVEs, all released within a couple of weeks. And you can see there, most of them were pretty significant. It was a 10.0, a 9.0, 5.9. And then the last one was recently lowered to a 6.6. And there's varying versions of Log4j. The one that fixes all of them is 2.17.1. And we can look at the EPSS score for all of those. And this is what they look like. So the way that they do these scores is it's just a percentage. So the likelihood of you being attacked and exploited on the very first one, the 44,228, is about 95%. That's pretty bad. You don't see a lot of that. Most of these are actually in the 99th percentile of all the rigs. You can go out to first.org and download every single day. They update the EPSS for every CVE known. So it's really a great resource. And then you can see here, the second one still 72%-ish, and then it started dropping off, and then it bumped back up. So even though it's a CVSS score of 6.6, which is, I think, a medium, off the top of my head, what would that be in your vulnerability management process? 90, 180 days, something like that? But the likelihood of you're going to get attacked by is about 69%. So putting those two together might change your mind on how quickly you might want to prioritize fixing and patching that. And then CVE trends, it's out of sight. It's no longer in the top 10. No one's talking about it now. So does that matter? Maybe. I mean, everyone's moved on to zlib and Spring Cloud Function and Spring4Shell, right? And every day there seems to be something new. But it is definitely something I think is part of that overall data picture that folks should probably start using in their process. So I wanted to go over a couple others, and I'm not even going to mention what they are at first. So I picked 2 random CVEs from this year. The first one's a 9.8 on the Richter scale. And the second one's a 6.3. So based on most people's vulnerability management program, they'd put that in the bucket. 9.8 would most likely be a higher critical, probably get that thing fixed in 7 to 30 days, depending on what your cycle looks like. Then we have a medium that might not be fixed as fast. The EPSS looks really bad. You've got the 98th and 93rd percentile. So you see the first one, it's like, oh geez, that's a 9.8 CVSS. But it's only about a 9.5% chance of exploit. So that might change your mind a little bit, maybe not, but it depends on what your external footprint is. And then the second one, although it's a medium risk, it's a 0.4, so 40%. So again, I think it gives you more info. It may make it harder at first, but designing a methodology around what these mean, understanding the data involved in the EPSS calculation, I think will help us prioritize these fixes a little bit better than having teams always jumping on something because, oh my God, it's a 9.8. And then on CVE trends, the first one is actually number 2, right, today. It's actually been number 2 for the last week, and the other one's not on the list. Any idea, the first one? Did anyone look it up? Spring for Shell, right? So, it's a problem. It's a 9.8, but as of right now, the EPSS score is only a 9.5. I think that will increase once the industry understands more about it, and there's maybe another exploit released, which we are predicting. The second one's a random.net issue, right? Yeah, go ahead, Ian.
I mean, given the stats that you had earlier, that 71% of apps are vulnerable to endpoint, do you think the EPSS score should be higher since that's not public data, right?
I don't know. I think it should, and I feel like it should. I do think it's hard to initially scan for, and there are certain things that have to happen. What I do think might happen is they will reevaluate the CVSS, and it might drop down because you have to be in Tomcat, you have to be running as a WAR, you have to be on Java 9+. I mean, there's all these different pieces and parts that have to fall into place for the exploit to work. However, there are a lot of apps that fall into that bucket. So again, I think it's partially there's not enough data yet. This actually, today was the first day that there was an EPSS, so I do expect that to go up. All right, and then the final risk layer, something that security folks don't get to talk a lot about usually. Does anyone manage licensing for open source in here? It's fun, isn't it? It's hard. Java and Node have lots of issues when it comes to high-risk copyleft licenses. So what I mean by copyleft is there's basically a requirement at a high level that if you're using a GPL or something similar license, you basically need to make your stuff open source too. So we don't want to use those in a lot of cases, especially if you're trying to monetize what you're doing and you have some IP that's really important to keep and maintain. You may be okay with it. Maybe it's an open source project that you're going to use. The stat here that's alarming to me is 99% of orgs have at least one application with a high-risk license. And a lot of organizations may not be aware of that. Legal teams, they ask for a list of things sometimes to look at it when maybe a customer or someone else wants to see it. But it really could create some significant IP issues for an organization when it comes to these different licenses. I mean, MIT, BSD, Apache, all of those are good. But then there's some that are kind of in between, the AGPLs and things like, or LGPLs and things like that have linking exceptions. So it gets really complex really fast. So I'm seeing more security products on the market that expose this info and make it kind of part of that overall risk profile for application owners. And it is something that I think we need to start tracking a little more closely because we're using more and more open source. and it's going to continue to grow. And we've got to understand those licensing risks for our organization. So those are the 5 risk layers and the risk layer 0 that I wanted to kind of talk about. This is not complete by any means. What I would like to be able to do is have an easier way to use more data and calculate true risk rather than just bowing down to the almighty CVSS and giving up and prioritizing based on that. Because I just don't think it's viable and sustainable as much open source as we're pulling into our organizations. So I think we need to set comprehensive policies and figure out what those measurements look like for us to really set how we prioritize risk with our open source. Establish that continuous observability. This isn't going to work if you have to push a button every quarter and pull your data, because after a quarter, that node library that you're using is probably 3 major releases beyond where you were 3 months ago. Right? So it has to be continuous. It has to be happening as much in real time as possible. Use all that data and calculate those decisions. Create your own CVSS based on the data that you have access to, and don't just rely on CVSS. I mean, the reality is that CVSS was meant to be changed by those who use it, but most people don't really modify it much. They may have some internal documentation that say this doesn't really mean that and it means this, but it was meant to be a little more extensible. And then embed those controls into your CI/CD and your pipelines. I think the one thing that as an industry we need to do better with is just enable developers to manage these things themselves. Developers are smart. They solve problems. You give them a problem to solve and they're going to solve it, especially if it means they can work on the things and innovate like they like to do, that they're best at, right? So again, this is a work in progress, but I want to get away from just the reaction to these 9.8s and these every month we're getting everything above an 8 CVSS and we have to fix them. But it's going to take a collective effort, not only between security and development, but your risk teams, your compliance teams. Those are going to be the hard ones. Those are going to be the hard ones to get through to. But the key here to get through to them is to document the process and why you're making those decisions. As long as those are there, I think we can get there. And that's what I had for you today. I'm Golf Hacker Dave on Twitter. Find me on LinkedIn. Questions, comments? Yes, sir.
Since they did the stock exchange, should we do something that?
Yeah.
Getting that too.
Start us.
Bad of doom.
Bad of doom. Bad of doom. Bad of doom. I like it. I like it. Anyone? Questions? Yeah.
So you talk about embedding controls into your CI/CD processes for this. As someone who's relatively new to trying to get this in our organization, where would you start? What tools have you seen? What's a good place to start for developers to kind of start pushing them in the right direction?
How do I say this without pimping my own org? It's a great question. So there is a lot of tooling out there that I think is good. Obviously, I'd love for you to look at Contrast. Sneak is always something that is really trying to embed that developer mindset. GitHub has a lot of advanced security and code QL and things built into, if you're using GitHub for repo and things like that. GitLab actually has a ton of free security things in the pipeline. None of them are going to provide all this data, and that's part of the problem. But it'll get you further than maybe where you're at and get you some of the data so you can start building out those risk profiles. Because anything is better than going to your developer and saying, hey, here's 10 CVEs, they're all 9.8s. Are we actually using them? Because what they do is they spend 2, 4, 6 days going back into their code and coming back and I don't think we do. I didn't find anything. And then you're still not really in a better place, and you have to make that decision, well, if we don't know for sure, we better just update them. So I mean, there's a ton of developer-focused, and that's the key, is the developer-focused tools. Not the ones that generate a report and they throw it on their desk and they have to fix them. It needs to be in a pipeline, in-process type tool that can help them. And there's a lot of free ones. You know, people don't have budgets sometimes. You know, I'd look at the GitHubs, the CodeQLs, things like that, that can start providing some of this data for us. Depend about, which isn't perfect, but it gets you a little bit further than maybe where you're at. Anything else? Awesome. Well, thanks everyone. Thanks for sticking with me for the last session.